Welcome to Materials Engineering program. Materials engineering is a science that studies the structure, process properties, and performance of a material. Areas studied include metallic materials, ceramics, polymers, and composites. These materials are later developed for broad applications such as materials for energy, medical, and nanomaterials. I will give you a quick tour on our laboratory. Materials Engineering program has Materials and Metallurgy Laboratory, which is divided into two parts, the Metal section and the Polymer and Composite section. This lab is used for teaching, learning, and research activities. Students can carry out activities in the laboratory to support learning activities in the classroom. Now, we are in front of the Metallurgical Materials Laboratory building for the Metal section. This laboratory is used for practicum or research activities related to metal materials. Let's take a look inside. In this lab, there are facilities that support students to carry out practicum in subjects such as mechanical testing practicum, material processing practicum, materials engineering and characterization practicum, and materialography and diffraction. Here, we have several machines to characterize mechanical properties of materials such as tensile or bending task machine, hardness task machine, torsion task machine, fatigue task machine, and also impact task machine. This is tensile or bending task machine used for testing mechanical properties of materials such as flexural strength, modulus of elasticity, elongation, and tensile strength. Next, we have the hardness test machine. This machine could be used to determine the hardness value of material through several methods such as Brinell or Rockwell hardness test. We also have a microvickers hardness test machine with automatic feature to determine the hardness value of the sample. For torsional testing of materials, we have torsion testing machine. And for fatigue testing with the rotational bending fatigue test method, we have fatigue test equipment. Last, we have the impact test machine, which tests the toughness of materials by either Sharpie or IZ method. Let's move on to the other room. Besides mechanical properties characterization, we have several equipment for visual, optical, and chemical characterization of materials. Visually, we can see the structure of materials in metallography through microscopes that we have in this room. This is our UV, visible spectroscopy. With this, we can characterize optical properties of materials. We also have Fourier transform infrared spectroscopy, which can be used to determine the functional group of the sample, mostly for organic materials. In this lab, students can learn about non-destructive tests, especially ultrasonic tests using this tool. In our lab, students can learn some material processing such as metal rolling, welding, heat treatment of metals, and surface treatment of metals. This is metal rolling machine used to reduce the thickness of the material either by cold rolling or hot rolling process. The effect of rolling process can be seen by the microstructure changes inside the materials. Students can learn the welding process using the shielded metal arc welding method. Now, we are in furnace area where several heating furnaces with different temperature limit can be used based on our need. These furnaces can be used in the process of heat treatment of materials. We also have the Gemini test equipment used to determine the hardenability of the materials. Now, we are in the polishing room. As the name suggests, here students can carry out grinding or polishing processes for metallographic activities. Right now, we are in polymeric and composites section, which is part of materials and metallurgy lab. This lab is located on the main building of Material Science and Engineering Department. This is our main teaching lab where several polymer and composite machines are used to conduct practicum activities in polymers and composite courses. Through this practicum, students can get a better understanding by hands-on activity in the lab. We also have viscometer, one of the machines used in the polymer processing practical module. It measures the viscosity of the thermoset polymers using torque. The viscosity will increase due to cross-linking reaction. The data is then recorded to make a graph. This is a melt flow rate. This machine is also used to indirectly measure the viscosity of the polymers, especially thermoplastic. Plastic resin is melted under a specific time, weight, and converted to the MFR value based on the standard. Here, we have the rubber and plastic hardness machine. We can test rubber with a wide range of hardness based on shore A and shore D. This is one of our plastic processing machines called compression molding to create material like this plate. We use a mold here filled with thermoplastic, then press using this hydraulic and let the polymer melted. Next, we have vertical injection molding machine that we use to manufacture materials like these tensile bar specimens. We can vary the time, temperature, and pressure during the molding process. This is our plastic extrusion line. Here we have a single screw extrusion machine, water bath, and puller. With this machine, we can manufacture continuous filament with different temperature, speed of the screw, and speed of the puller. We also have 3D printer machine. This machine is used for testing a filament made from various types of polymers. Also, we test our own developed filament here. This is the area for making a composite, especially fiber-reinforced polymer composite. The process begins with designing the composite. Next, we make the composite through various methods, wet hand layup or compression molding. Then, just let the resin cure. We got the composite to make these tensile bars for the tensile test and small sample for burning test to check the volume fraction of fiber and matrix. Last, do the analysis. To make a rubber compound, we use 2-roll mill machine. Here, we mix various chemicals to make different recipes, which is then vulcanized using a compression molding machine to make a sample test. I will show you our fume hood. This is where we do material extraction using this magnetic stirrer and sock sled. Also, we do reaction here using a volatile solvent. Thanks for joining us on our tour of the Material Science and Engineering Lab. We'd love to see you in person soon!